Okay, try and get a few questions on this one. Okay, so this one is a circuit question. Draw a circuit diagram with correct symbols to show a battery of 4 cells, so looking at 4 individual cells, an ammeter, and an LDR, light dependent resistor. Anything to do with resistance has a square box in there, an oblong box. If it's light dependent, then the arrows are going towards it. Okay, and it's all connected in series. So you need to know your symbols. So you draw your 4 cells across the top, an ammeter, and then you would put the LDR in and then just connect it back up. Okay, there's 3 marks for that one. Okay, you use your pencil, you use your ruler, no gaps in the circuit. Okay, moving on. Add to your circuit diagram an LED connected in series so that it is glowing. Okay, so an LED, light emitting diode. So in this case, the arrows are going to be pointing out. It's creating light, and you will put that into a circuit. Okay, make sure it's facing the right way around. A cover is put over the LDR, so it's in total darkness. What happens to the LED for 1 mark, and then what happens to the ammeter reading for 1 mark? So the LED is going to go more dark, it's going to be less bright, it might even go out. The ammeter reading will decrease, go less. And what's causing this change? Well, the LDR, when it's in darkness, the resistance is very high. Okay, as soon as you put light on it, the resistance decreases, so the current starts to flow. A bit like I've always said about, an exploding bomb. Yeah, you'd build it in the darkness with a LDR, and then whenever it was delivered to the person, they took the lid off, the light would shine on it, resistance would decrease, current would flow. So for 2 marks in this case, we have to say that the resistance of the LDR is greater in the dark, and that causes a decrease in the current. Okay, moving on to this one, which is Mum Fancy's dad. So, diagram showing the lever, very often a seesaw, and we've got some forces and we've got some distances. Write down the equation to enable you to find D. So because it's balancing, the moment on this side must equal the moment on this side. Moment equals force times distance, so we could write 6 times 8 must equal D times 4. Okay, it's only given 1 mark, so it only wants you to write that equation. Then it says, assuming the lever balances, use your equation to find distance D. So you're just going to churn through that equation, and you're going to end up with D equals 12. Okay, and you can put the units in there, although it doesn't ask for them. So the distance we're using is centimeters, so it would be 12 centimeters. Okay, weight of the lever is 3 newtons. What's the total downward force on the pivot? So we look up here, we've got 6 newtons on here, 4 newtons on here, and this lever, this bar, weighs 3 newtons. So 6 plus 4 plus 3 gives you 13 newtons. Okay, so 13 newtons your answer there. Again, these, I always worry about these because there's no dotted lines, so people forget them. Draw a labelled arrow on the diagram above to show the force exerted by the pivot on the lever. So we would just put an arrow pointing down here to this point here, the pivot. And it says, what is the size of this force? Well, the size of that force is the answer you put up here. So it's 13 newtons. 6 plus 4 is 3. Okay, this one is a graph question, and it's about renewable and non-renewable energies. So wind is an example of renewable. Name one other. So you can't put wind down for that. Okay, so we're looking for something like solar, yeah, wave power. Explain the meaning of renewable when describing an energy resource, and they're giving you 2 marks for this. So remember, we need to talk about the time of this. So if it is replaced within a lifetime or 100 years, then it's classed as renewable. So even biomass, you know, like growing trees and then burning them, that's classed as a renewable. Okay, so we need to mention the time scale, and we need to say that it's replaced continuously or something along those lines. Okay. Next one, a word fill. So wind farms are used to transform some energy of the wind into what type of energy? So we're looking at the kinetic energy of the wind, and then that is obviously going to generate electrical energy. Next one is a graph, and before we move to that, this is obviously the independent. We've decided to look at 0, 5, 10, 15, 20. Independent, I, so I sits on my bottom, so this will go on the bottom scale. This one depends on what scale you use down here. Okay, so that's the dependent. So let's click on to that, see what we've got. Okay, so they've labeled the axes. So they're looking for you to put a suitable scale across here. Okay. Make sure it's an even scale. And I always suggest that you start at 0 anyway, but they're actually forcing you to start at 0 on there. Remember, accurate plotting, half of one of these tiny boxes, it needs to be within that region. Okay, so if it should be there and it's up there, you're not going to get the mark. Okay, so be really careful with your plotting. As I always say, sharp pencil, ruler, don't use pen. Plot the point, then have a look at it. Look at the pattern before you draw in the line. It's not always, even if it says drawing a line of best fit, it might be a curve. So see what you get. Again, these, don't be fooled, no dotted lines, you still need to do it. So plot it accurately, have a look at the pattern, draw in the line or the curve. It might not be a straight line, it might be a curve. E, suggest why there's no energy transformed if the wind speed is too low. So if we look on here, wind speed is low and there's no energy being transformed. Well, obviously you get the wind turbine has a lot of weight attached to it. You've got to overcome that weight, you've got to overcome the friction. So you need the wind to be blowing quite a bit before you actually start to generate any energy. Suggest why the energy transforms every second is greater at high wind speeds than at medium wind speeds. So, for 1 mark, faster wind speed has obviously got more kinetic energy. It exerts a greater force, so it's going to generate more electricity. And moving on to the final one. Diagram shows a brick, and it shows those dimensions. For 2 marks, straightforward maths question. Calculate the volume of the brick. So we are looking at 20 times 10 times 5 to give you 1,000 cubic centimeters. 2 marks. Next one, going to the scales, what's the mass of the brick in kilograms? So again, another straightforward one. This is halfway between 1 and 2, so we're looking at 1.5 kilograms. Next one, calculate the formula relating, so my dog vomits. So we've already done the triangles at the start of the exam, and they're actually asking for density. So density equals mass divided by volume. Then this one, a little bit tricky, 2 marks. Calculate the density of the brick in grams per centimeter cube. Okay, we've got what it is in kilograms. So you'd need to convert that first before you did the calculation. So mass would be 1,500 grams. So the density is going to be 1,500 divided by 1,000, which is your volume. And that gives you an answer of 1.5 grams per cubic centimeter, those units. Then we find out the brick has part of it hollowed out. So, does this mean the value you've calculated for its density is too big or too small? Well, it's actually too small because it's more densely packed because we've had to, a bit has been hollowed out. So the rest of it is more densely packed. Again, as I always say, there's only 2 options. It's 50-50. If you've no idea, please write something. Suggest how, with the help of a measuring cylinder, you could find the volume of the hollowed out part for 2 marks. So what you could do is you could put some water in there, and then you could measure out take that water into a measuring cylinder to try and work out what it is. Or you could use sand or something like that. Yep. The weight of the brick is 15 newtons. Complete the formula which relates pressure, force and area. So French people are annoying, so you just put pressure equals, which is force divided by area. Show that the brick exerts pressure of that when resting on its largest surface. So we know the pressure, we know the force, which is up there, 15 newtons. The area, we're looking at this brick, and it's going to be on this side, that's its biggest area. So obviously this is the 20, and that's 10. The 5 will be up here, it's a smaller measurement, so 20 times 10, so we look at 200. So into here, we would say pressure equals force divided by area, so we would do 15 divided by 200, and hopefully that will come to 0.075, which is the answer we've been given. Okay, thank you.